Um, in lecture number 12, Power Electronics, we have discussed about various performance parameters of a full converter. So let's apply whatever concepts we have learned in lecture number 12b and use all the formulas to solve this numerical. So, in a single phase full converter connected to a 230 volt 50 Hz source is feeding a load R, which is 10 ohms, in series with a large inductance that makes the load current ripple free. So basically it is a single phase full converter with RL load. Now for a firing angle of 45 degrees, calculate the input and output performance parameters of this converter, right? So we have been given the value of V in RMS, which is 230, R value, load value is 10 ohms, and the firing angle alpha is 45 degrees. Now this will be the sequence to follow. First we will find out V out average, followed by I out average, V out RMS, I out RMS, the DC power, AC power, PAC, then the rectification efficiency, eta, form factor, then ninth will be voltage ripple factor, then current ripple factor, then the fundamental value of the current I in 1, then phi 1 is my displacement angle, then displacement factor dF, current distortion factor CDF, harmonic factor HF, and active input power PI and reactive input power QI. So this is the sequence we will follow. Now this is the given data. V in RMS is 230 volt, R is around 10 ohms, alpha is 45 the firing angle, and we are dealing with single phase full converter with RL load. Now for this converter, the average value of the output is given by the formula. V out average is equal to VDC, which is equal to 2 Vm by pi cos alpha. Now Vm is actually root 2 times Vrms, so it will be 2 into 230 into root 2 divided by pi into cos of 45 degrees. So if you solve this into calculator, you will get a value of VDC as 146.423. So please check this answer. Next, we find out the value of I out average. So that is written as IDC, which is nothing but V out average divided by R. And R value is around 10. So it will be around 146 divided by 10. That will be around 14.6423 amperes. So that will be the value of I out average. Now for a single phase full converter with RL load, we have derived earlier, V out RMS is coming out to be Vm by root 2. So that will be Vm is root 2 times 230 divided by root 2. So that means V out RMS value is 230 volt. Next, we find out the value of I out RMS. Now as the load current is ripple free, the RMS value of the load current is given by equal to average value of the load current, which is 14.6423 amperes. Next we calculate PDC, which is nothing but uh, the product of average value of the output and the average value of the current, output current, that is VDC into IDC. The values are determined from the earlier steps. So the VDC step over here is 146.423 and IDC value is 14.64. So the product is coming out to be 2143.97 watts. Next we calculate PAC and its formula is VRMS into I out RMS. So V out RMS is 230 and I out RMS is 14.6423. So that product is coming out to be 3367.73 watts. So once we know the value of PDC and PAC, we calculate the rectification efficiency, which is given by PDC into 100 divided by PAC, and that rectification efficiency, if you calculate it, it is coming out to be 63.66%. So that's my rectification efficiency. Next, we find the form factor, which is FF, which is given by the formula V out RMS upon VDC. V out RMS is 230 volt, and VDC we have calculated before, it is 146.423, and this division will give you form factor as 1.5708. So please cross check this answer. Next is voltage ripple factor VRF, which is nothing but form factor square minus 1 raised to half. So if you substitute the value of form factor obtained in the previous step, you will get a value of voltage ripple factor as 1.2114. Now, next is current ripple factor, which is CRF. Now, as mentioned in the numerical that the load current is ripple free, the current ripple factor CRF will be 0. Next, we find out the RMS value of the fundamental current, which is I in of 1, uh, which we have discussed in the lecture 12b. Now, this formula is I in of 1 is 2 root 2 times I out average divided by pi. So, I out average value is 14.64 divided by pi, and it will be multiplied by 14.64 is multiplied by 2 root 2. So, I in of 1 is coming out to be 13.183. So, please check this answer. Next point we have to calculate is displacement angle, which is phi 1. This displacement angle is equal to minus of firing angle, which is minus 45 degrees. Now with this we find out the value of displacement factor df, which is cos alpha, where alpha is 45. So cos 45 is around 0.7071. Next is we find out current distortion factor. This current distortion factor is a fixed value for a full converter, which is coming out to be 2 root 2 divided by pi, which is coming out to be 0.90032. Now, once we know the current distortion factor and the displacement factor, the product is equal to the input power factor, PF. So, PF is CDF into DF, which is zero point 0.9 multiplied by zero point 0.7. This is coming out to be 0.6366. So, that's the value of the input power factor. You can cross check your answer. Next, we find out the harmonic factor, which is harmonic factor is actually equal to, let me just maximize the screen once. Okay, okay, just a second. Yeah, we'll exit the full screen and we'll continue to solve the numerical like this. So next, after finding the power factor, we have to we are finding harmonic factor HF, which is equal to 1 upon CDF square minus 1 the whole raised to half. So CDF is around zero point 0.9. So 1 upon zero point 0.9 square minus 1 raised to half. So that comes out to be, harmonic factor is coming out to be 0.4834. Right? That's also a fixed value in full converter. Now, next we find out the active input power PI, which is given by the formula 2Vm IDC cos alpha divided by pi. Vm value is root 2 times V in RMS, which is 230. IDC value is 14.64. Alpha is 45 degree. So if you put it in the calculator, it will give you the result as 2143.96 watts. Now we'll similarly find the reactive power. Reactive power will be 2 Vm IDC into sine alpha divided by pi. So sine alpha here it will be sine 45, which is value you can calculate it in the calculator and substitute all the other values, and the value comes out to be similar to pi. So the reactive input power is coming out to be 2143.96 VAR. That's the unit of reactive input power. So in this way, these are the various input and output performance parameters of a full converter. So normally this numerical is can be asked for around 10 marks, and the data which is given is minimal, which is V in RMS, R value, inductance value is very large, so that it makes the load current ripple free, and a firing angle will be given. So whenever we have to calculate input and output performance parameters, it's better to follow this sequence. Yeah. So that's it for this numerical session. Next time we'll start with semi converters. So until then, have a good day and thank you.